Good afternoon. Welcome everybody. Welcome to the webinar. As most of you know, this webinar is in preparation of our Solar Asset Management Conference in Milan, coming up on the 7th and 8th of November. We are very much looking forward to welcome all of you there as well. But we will share some more information on that in a couple of minutes, or actually after the webinar. Some technical details. If you have any questions to either me or one of the speakers that I will announce in a bit, please feel free to use the chat function that you see on the right side of your screen. My colleagues will take note of the questions, try to answer any technical questions you have. But if it's a question to one of the speakers, we will address them after the webinar. So it's approximately going to be at 5:15 Amsterdam time. My name is Ilke Hoogduin. I'm a project manager at Solarplaza. I'm in charge of the Solar Asset Management Conference coming up in Milan. Already the 5th edition, and we're still counting, but it looks like it's going to be the number 100 event of Solarplaza. So we're quite proud of that, and of course looking very much forward to see you there again, or see you there for the first time. Conference will be at the Sheraton Airport, Milan, Malpensa, and we will cover a lot of technical O&M topics, but of course also a lot of asset management topics. And yeah, there's some, of course, we see a lot of activity in merchant solar at the moment. So how to deal with PPAs, how to deal with traders. Yeah, what's the plan for operating your plants in environment that is completely exposed to the electricity market. We will cover all of these topics extensively. The program is already online at the website. Just head to solarplaza.com or solarassetmanagementeu.com, and there you will see who the speakers are and what the program comprises. Big thank you to all of the sponsors of this conference, including the gentleman that I'm about to introduce. Without these sponsors, of course, it wouldn't be possible to organize these conferences. So once again, thank you. Yeah, so let me introduce you to the first speaker. That will be Donald van Velsen. Donald, can you hear me? I think you're still muted. There you are. Can you hear me, Donald?
Yes, I can.
Welcome. Donald is product manager at Kipp and Zonen, long-term relation of Solarplaza. Very happy with that. So let me just briefly go through the agenda of today. We talk about different soiling scenarios depending on the location, different technologies to measure, to analyze and measure soiling on your PV plants. And as you can see the agenda here, there's 3 more topics we will address. Let me go to the next slide. There it is. So this is the conference I just talked about. We expect about 350 to 400 people in the room this year, representing the complete value chain from service provider to asset owner. And we're happy to announce that there's quite a few new companies in the conference that we haven't seen before, with some very interesting technologies and services that they can talk about. Let me open up the slides of Donald. Donald, please introduce yourself briefly, yeah, the floor is yours. Go ahead. I will give you control on the slides as well. You should be able to present now.
Okay, thank you very much, Ilko, and thanks to everybody for taking the time to attend this webinar with, from my part, the Dust IQ information and updates. I'm Donald. I'm a product manager at Kipp and Zonen in Delft, the Netherlands, and I'm responsible for 5 new products this year. Some of them small and some of them big, like the Dust IQ, which is really a big one for us. Since I've got just 20 minutes, I'll keep moving on. Please feel free to raise questions using the chat window, or otherwise you can raise questions in person in Milano, as I will be there. Okay, let me try, Ilko, if I can move the slide one further. A very short introduction of Kipp and Zonen. We are instrument makers in Delft, the Netherlands, since 1830, so almost 2 centuries. And we have been making solar measurement devices for almost a century. And the first solarimeters indeed were produced in 1927, coming all the way to our all smart and digital solar measuring instruments in 2015, and in 2017 on the we introduced the Dust IQ at the Intersolar in Munich. As said, we are indeed instrument makers, and we are quite good in making equipment that is very well designed for freezing cold and desert-like heat. We are not meteorologists, and we're also not soiling and cleaning experts. We are indeed instrument makers. The Dust IQ, as I will introduce further on, is our first real new product for a real new market. To clean or not to clean, that is the question. On your left-hand side, you see a pyrometer measuring the solar radiation, and in most cases it is just a nuisance when it is dirty. And I don't have to tell you that on the right-hand side with the solar panel soiling me equals money, and the more soil there is, the more money you are losing. From there we get the first poll question. Oh, Ilko, help me out here.
Yeah, we're working on it.
Oh, sorry.
We're launching the poll as we speak.
Oh, yeah.
Is it visible? Yeah, I cannot see it. So, are you currently measuring the effects of soiling in any way? Please press yes or no if you're if you're owning or operating any PV installation, any PV plants. We give you a couple of seconds to answer the poll.
Yeah, we would be very much interested in knowing if indeed you have found any way to measure the soiling already. Okay, well, that is good. Definitely good. 60% already has equipment to measure it in any way. Thanks very much for that. And I'll just move on here. I'm not going into a detail as I only have 20 minutes, but as you are aware, the soiling is can be very much different all over the world. It can be different even on a micro scale, of course, when you're close to local soiling producers. That could be factories, that could be burning waste, it could even be burning whole forests, like unfortunately people do in Indonesia. And in some places, of course, they are, well, sort of lucky to have rain once in a while, as that also has a very big cleaning effect on the panels. So soiling, of course, is, well, the worst in the real arid or semi-arid areas on the world. Oh, that is one too fast. Okay, this is a soiling map that we came across during all our research. It shows the amount of dust all over the world, and it's of course not really surprising that, you know, desert-like areas are the worst. Some parts of China are bad, even India, and the real southern part of South America is very bad. an awful lot of difference in the composition of the dust, from very fine silt and clay up to coarse grained, well, let's just call it sand. One could easily become a professor in soiling, we discovered, and maybe even a Nobel Prize winner in 10 or 20 years' time. Data is available for free on the internet when it comes to soiling and dust. And of course, it can be bought or even measured locally. From this, just a short, probably a recap of what you might already know or might not know. Transmission loss, often talked about. Transmission loss, fairly simple, is the light not reaching the actual silicon cells due to soiling. If you've got 10% transmission loss, you're losing 10% of your light, which is almost equal to losing 10% of your electricity production. I want to move on to the next. Okay, I had to click 5 times. Soiling ratio, that too isn't really that difficult. Soiling ratio is the power actually produced divided by the power possible, you know, the maximum power that you could be producing if the panels were complete squeaky clean. And in most cases, the soiling ratio, when you do it in a percent, is 100 minus the transmission loss. So a soiling ratio of 100% would mean absolutely clean panels and no loss due to soiling. Why you have to measure? There can be several reasons for it. It could be in your contracts when you are an EPC or an O&M company. You could be following the latest IEC 61724 instructions as published earlier this year, or it could be local legislation, sometimes combined with special rules in order to get a subsidy for the solar plant. Where on the world? Well, I've shown you that, you know, on the soiling map, all arid and semi-arid areas, or areas with the local polluters, and the local polluters could even be as bad as a volcano erupting, of course. How many times in a solar park? It sort of depends on the size, the terrain, the wind uniformity. You know, in an ideal world, you would only measure it on one spot and then, you know, take that measurement as valid for your whole solar park. In most cases, you know, that will not be the case, and that's also, you know, when you follow the IEC recommendations, you would have one measurement device. You know, doesn't really matter which kind of system, for every 5 megawatts if it's a small park, up to 1 in every 100 megawatts if you're really looking at, you know, 500 to an 800 megawatt solar park. That brings me to the second question. Can you help us out? Great. Yes, and we really would like to learn from you if you are aware of this document released earlier this year. It describes what to measure, how to measure, and how often on a solar park to measure.
All right, we're closing the poll, I think. Just a couple of seconds. There we go.
Okay. Well, thanks. Okay, that is a bit surprising, at least from our point of view, because it can be a great help, you know, if you're doing monitoring on a solar park. And, you know, it's not just about, you know, in our case, measuring solar irradiation or soiling, but it's also about wind, PV panels, how often, where, which with accuracy, calibration intervals, logging intervals. It describes an enormous amount, and well, you have to buy it from the IEC, but 270 euros or Swiss franc, it's nothing compared to running a solar park, of course. The equipment that has been around for quite some time to measure soiling ratios, and which is also used in the current IEC recommendations. These bits of equipment are not bad, not bad at all. We didn't invent the Dust IQ to come up with something better from a technical point of view or a measurement point of view. They always consist of 2 panels. One is kept clean, either using a robot or using local labor, and the other one gets dirty, and then you do the math again to get the soiling ratio. The reason that we came up with the Dust IQ is that, well, we thought that we could come up with a system that would need less attention, less mechanical parts, and would also be more affordable. So that's here the Dust IQ that we have introduced and are almost finished with the latest steps in making it a commercially producible item. It's got 2 sensors. It uses modulated LED light, measures soiling ratio for you. It always comes with a PV panel temperature sensor, which is NREL or IEC compliant, so it fits all the rules about isolation and heat conductive tape. It has PV panel dimensions, PV panel glass. It is actually made by a company for us that makes PV panels, but only much smaller. It weighs 4 kilograms, so it can easily be mounted even on a 1 or 2 axis tracking system if you would like to do so. And it uses RS485 Modbus connection, which is very common in this world. And last thing is that the Dust IQs are daisy chainable. So if you have several of them, you can daisy chain them and still have one cable to your host system, your SCADA, or maybe your data logger. Very short the way that it works. As said, we use a modulated photodiode signal. We call it OSM, optical soiling measurement. When the panel is clean, there's no soiling on top of it, only a little bit comes back, and when there is dust on it, more modulated signal will come back, and that's the way we measure, and that's the way we can also avoid being influenced by the sun. It also allows us, by the way, to measure early in the morning, late at night, or even during the night. This is the way that we have set up all our tests. This is one of our first tests with bits of PV glass that have been soiled with several degrees of soiling. And we used our pyranometers to measure the actual transmission loss to come to a relationship between measurement and transmission loss. The Dust IQ 1, 2, 3 approach, as we call it, we measure the reflection. We then use the internal computer to do calculations and come up with a transmission loss, which is reported using a Modbus address. And from there, we also report the soiling ratio to be in line with the IEC recommendations. Obviously, there are very many variables. You can have different kinds of dust, colors, grain size, everything. And we've done an awful lot of measurements on there to figure out what would happen to our measurement results. And all this is now in the intelligence within the Dust IQ program that we use. We have done extensive testing on the influence of grain size, and much like Other researchers have found the grain size doesn't really matter that much. In most cases, the fine dust will really stick to the panel. Coarser, sand-like dust will in the end roll off, but even if it is stuck there, it doesn't really influence our measurements. Yeah, this slide I have just been updating as we initially started when we launched it at Intersolar in Munich, with a color chart, a dust color chart, a bit of a copy of the Moonsol chart for all kinds of dust all around the world. And we sort of decided not to really go that way and improve it by installing a small silicon cell in the Dust IQ itself. Later this year we'll share more information on that with you, but having a small silicon cell in the Dust IQ itself will enable us to do a local calibration with your kind of dust in your situation. And by cleaning this silicon cell only once, after the first 3 or 4 weeks of the Dust IQ being installed, you do your own local calibration. Silicon cell will be around 300 square centimeters, so it will have a good representation of the dust on a real solar panel. This setup will probably also allow you to have several calibrations if your dust composition changes over the year. As you can calibrate one Dust IQ, store the value, read it from the device, and distribute it over your park to the other Dust IQs. The Dust IQ will give you a sorting ratio which is valid for perpendicular light. So it is a valid measurement round about solar noon, when the sun is at its highest position. The influence of the soiling on the actual soiling ratio as measured when you have a 2-panel system, it differs over the day. And later in the day, when the sun is lower, the effect of the soiling is worse. So you have more loss. But we are aware of that, and there are calculations for it to take care of the soiling ratio changing over the day. And another click. Yep. And that's why there are several forms of what we call after processing of the data coming out of the Dust IQ. The Dust IQ implementation number 1 is just straightforward. You will get 2 sorting ratios from the Dust IQ, and they are valid perpendicular sorting ratio, so valid for about 2 hours before and after solar noon, which is, not the best possible. On the other way, it is comparable to most existing 2-panel systems. As these also are the most accurate and have the lowest uncertainty around solar noon. The second implementation that some of the software companies are already working on is incorporating the Dust IQ in their solar monitoring software, writing their own algorithm. It is public knowledge. It's out there on the internet. Have that in their software, and then take the data from the Dust IQ and calculate the actual sorting ratio, let's say 5 in the afternoon. And the third implementation is when we will introduce a cloud service. So the soiling monitoring software doesn't really need to be aware and have the calculations for the best soiling ratio, but it can simply send out a short message into the cloud and get enriched or enhanced soiling ratio values back from our service. The question that we have been asked quite a few times is, why are you using blue LED light and not white? Because dust can have every color. The research team at Kipp and Zonen has selected, a blue LED because it offers long-term stability and also temperature stability. White LEDs by nature are very sensitive to the temperature and not stable on the long term. And we are looking at a system that is installed in between solar panels. Oops, sorry for that. That was my alarm. So it should be working without any problem for 5 and even better 10 years. And it's also part of our passion for precision. Conclusions. Dust IQ will prevent daily cleaning. It will not have moving parts. It will not use water. The price will be such that indeed, as you can see in this picture, you could have several among the PV panels so that they catch the same amount of soiling as your PV panels do. And it will also improve the ease of installation, as the panels are almost PV panel-like. They're only a bit smaller. What we have already demonstrated, not here in this presentation, but out there, is a high sensitivity and precision. We're aiming at transmission loss figures, plus or minus 1% accurate. The signals are linear. Doesn't really matter how big the grain size is, and you will be able to do local dust calibration for your specific site. And we're still working hard on the latest model, as said, with the built-in silicon cell to have it tested by independent people, and so that they can publish a paper. And as soon as we have them, we will share them, obviously. First commercial delivery later than we hoped for, later than we expected, but we are incorporating so many customer requests already that we're now aiming at the beginning of 2018.
And there's the last poll.
Yeah. Yeah, well, since 60%, I think, in the first question was already using something, probably the answer will be yes here as well.
Just a couple of seconds. Give everybody some time to vote. Collecting responses. What do you expect, Donald?
Yeah, I think it was 60-70% yes that already measured, so I expect at least the same here.
Okay, let's see.
Okay, well, they all are already okay. Well, that is something for me to take back to the office. Okay, I'll just skip that, and it leads me to a big thank you for everybody attending this webinar. And if you have questions, please let us know.
Thank you, Donald. We will continue with Gerhard in a couple of seconds. Yeah, maybe in the meantime, we're gonna address all the questions after the webinar, but just a very quick one. Could Dust IQ be used to measure soiling due to snow?
No, it can't. No, currently it is completely unaware of the effects of snow. We have been asked before, and maybe later next year we might come up with a snow IQ. Currently it's called Dust IQ because it's good at measuring dust.
What's in the name? Yeah, it makes sense. Okay, thank you for answering that. Please, remain standby, as we will address quite a few more questions after the presentation of Gerhard. And yeah, there's one question I can already answer is, will the Milano conference cover PV soiling? Answer to that is yes, in a way. It will be one of the subtopics. Not too much in depth this year, but I can tell you, if you're really interested in this, you can go to Santiago de Chile, which is our SEM LATAM conference on the 17th and 18th of October. So my colleague Marcel is actually at the moment on his way to Chile already. And yeah, of course, in Chile the environment is a bit different. So there it's one of the biggest topics in O&M. In Europe, depends a little bit on the country, but this year, yeah, there's no full presentations or panel discussions on soiling, but the topic will be touched upon in a couple of panel discussions on general O&M. So let me please introduce you to Gerhard. Gerhard, can you hear me?
I'm already here. Yeah, for sure.
All right. Let me just
welcome to everyone.
Bring up your presentation.
Start.
And give you control over my computer. There you go, Gerhard. Please introduce yourself, your company, and go ahead. You should be able to control the presentation from there.
Yeah, I cannot see my slides at the moment.
That is my bad. There you go. Can you see it now?
Nope.
Gerhard, are you still with me?
Here I am. Yes. Okay. I'm still with you. Can you hear me?
Yes, excellent. Please go ahead.
Okay, that's nice. Hello, everyone. I'm Gerhard Mütter. I'm Technical Director of Alternative Energy Solutions, and I will talk to you about the quantification of soiling using advanced data analysis. This is because we did not have these nice tools like Donald presented us in the slides before. And I will show you our experiences. I will start, where is this to, next slide. Okay, I will start with just a short overview about our company and our competencies, and we'll talk a bit about soiling from the point of view of an O&M and of an owner, and we'll talk about our methodology that is part of advanced data analysis system called AES-PIT, and we'll show you some results. Now, let's start with a short introduction. What are we doing at Alternative Energy Solution? We make development service, EPCM service, and asset management. And so we are a service company. Most of the time, we work at an owner representative and take care that plants that are already existing run at the highest possible level. One thing that I will have to show you here is AES-PIT, that is our advanced data analysis system that is based on monitoring data, and these algorithms like Donald already showed you before. And we are trying to enhance during the whole life cycle of a PV plant and get up additional losses on detecting them earlier than with the usual measurement tools that you have. So let's start with a little warm-up, and this is now my first poll. Let me just explain a bit what's the question, a bit more complex and not only yes, no, but I think also more interesting. It's just to imagine how much money you can change if you take care of soiling. And I took here a 50 megawatt plant that is a medium-sized plant. I took an average day in order to avoid differences like day profile. Donald showed you also the annual distribution is a bit different. I took a location where most of the PV plants are, in this case, northern Italy or comparable. You can even take it down to Sicily, you can take it to southern Germany, and east-west, there is no problem if you come from Spain, France, up to Ukraine. I took a nice, at the moment still nice, but on older plants, absolutely available feed-in tariff of 20 euro cents per kilowatt hours. And to make it simpler, I took a quite bad soiling rate of 10% in park average. So there are distributions all over. Don't not discuss about this, average 10%. And I want to ask you, what are you thinking? Yeah, nice. So Eiko, you take it over.
Yes, we are currently counting the votes. Actually, the computer is doing that for us, fortunately. So let's wait a couple of seconds until we get the results in. People are still voting. Yeah, I think we can show the results here. So there we go.
Okay. Yeah, that's quite nice. So the people know what they are losing. What I see, more than the half think that the losses are higher than expected. Give me back my screen, please.
Yep, hold on.
Mhm.
Does it work? Yep, there you go.
Here we go. Here we go. Here's the result. So the highest result we had on that range from 1,000 to 5,000 euro a day on this 50 megawatt plant. That looks not very much, but you have to, and it is also nice to get this number. And I think this number is not hard to keep. 10% soiling means 100 euro per megawatt peak and day that you're losing. 100 euro per day is not much, but if you consider the whole year, it's 36,000 euro. If you have 2 megawatt, you can earn a second technician. If you have a 50 megawatt plant, it is twice nice, because then you get also a manager pack and his car. On the other hand, it is nice, but you have only on a private 10 kV plant on the rooftop, you have only to count with approximately 365 or not more than 400 euro a year. So in larger parks, it is quite necessary to do it, because you can earn a lot of money, you can get a lot more out of the plant, and that's what we are specialized. Let's now go a bit more into the details how soiling on the modules takes place. I've collected here from our experiences all over the world a few nice pictures of different kind of soiling. You see here nice picture of some nice decorated Indian plant, black modules that have been black sometimes. You see here only 4 fingers on a standard crystalline module. In the center there is one of the most tricky soiling situations, because if you have the highest soiling at the lowest cell, then you get there additional hotspots, and also the lowest cell defines how much the soiling impact is. Also the soiling rate, the local soiling rate is relatively low, especially on the upper cells. The lower cells gives the tact, so the most dirty cell is the tact, is the reference for the whole string. The picture you see under this green area here is a quite nice example to show that the local wind situation and the local pollution situation goes really down even at cell or module level. You see here very nice high soiling beneath the clamp, where the wind allows more particles blown on the surface and prevent you from getting everything that you can get from the sun.
Gerhard, sorry to interrupt. If I saw it correctly, there was a thin film module on the bottom right there.
There was a thin film module. There was 2 thin film modules.
So we actually got a question in. Is there any reason why thin film modules attract more dust in the same place? Is that a statement you agree with? And
I think the answer. Let's go back one slide. The answer is the slide is the picture in the middle, because thin film are usually oriented a bit different and equalize more and distribute more the current flowing. Not everything has to go through the cells, so it is thin film is not so critical on dust that is only local, like you see here in the center with these crystalline ones. Anyway, if you have 10% dust, you have 10% dust also on thin film. So it is a bit better, especially in situations where there is concentration on the border. And that's why also in India is. And the second question, and the second reason why thin film models are better is most of the thin film models have no frame. And the frame is always some kind of border to avoid that the dust is washed away.
Okay, thanks.
Okay. I think we can go now to the influence factors, and this will also answer these questions that you already did, Eco. We're talking about the influence factors on soiling is the soiling intensity, what comes from the environment. Another quite interesting impact is the duration. How long is the soil there? If you have a sandstorm that comes in front of a thunderstorm, and 10 minutes later heavy rain is coming, then you have no impact. Also, you have a temporary soiling of up to 30%. That is not a problem if it lasts only for half an hour. But if the soiling is taking 5% the whole year, it is much more terrible for your pocket. And the size of the plant is quite an interesting factor, because the larger the plant, the more you can change. In summary, model type we were talking about, this frameless glass and this alu frame is one thing. Also the more equal distribution and being not so spotty. The tilt of the models, because if there is a more intense tilt, if you have 60 degrees or more, dust and dirt will not stick and will not stay so long on the glass. It is quite clear. One of the things also Donald in his presentation showed is the local climate. So when is the rain? Are there seasonal changes? Are there daily changes? What is about the wind situation? And here you have to take care. This has been for every model different, and you've seen it on the picture before. The environment already shown is one of the thing, and the adhesive strengths of the material. Is it sandy? Is it oily? I can tell you an example of a plant in northern Italy that is direct near the runway of an airport, and because of this evaporated fuel of the jet engines, we have here 2.5% higher permanent soiling due to this oily adhesive strength. And of course, the surface, standard glass, plastic, and coating is also an impact. Coating on this, in our experiences, is only working if you have it on the models. If you do it from the production, if you do it later, it is not so really perfect, because the next rain will wash it away. Let's continue with one factor that you should also consider, and you see here 3 nice pictures. One, working with concrete in the plant. If you update the foundation on the upper and on the right slide, you see it, picture, you see it here, is also soiling. And take care that your subcontractors that are working in the plant know that they do not leave the modules dirty. And the other picture is a really nice picture of the human factor, because in the logbook there is standing this string is clean, but cleaned were only the first 10 models, and that not perfect. So you have also to double check especially in large plants, if the team has really done what they should do. And for that, we developed advanced data analysis, and this works like an algorithm toolbox with machine learning and a lot of mathematics in the background, and we check a lot of details and faults that are in huge plants. And here we help based on the monitoring data, not visible direct on just tracking the numbers and making a snapshot, but also considering the historical development of the park and the reaction time on different impact factors. So the difference between normal monitoring and working with advanced data analysis is like you having a picture of the plant, that's a snapshot at the moment, or you have a movie of a plant, and in the movie you see everything that is going on during the operation. It is working, taking the monitoring system data. The basic methodology is quite simple. The tricky thing are the algorithms behind, and that would just be too long to stay there. But we're taking, whenever we get measurements of local parts of the plant and compare them to similar other parts of the plants, and based on the differences on the different behavior, we can then go on these patterns that we see, isolate different levels of fault. That is just another view to the same thing. And from process to doing this, we started with monitoring data collection, make some pre-processing, make the analytics, and give them our clients reports. And as soon as we do this continuous, these alarms are only if some failures are coming up, because we know now how the park is working. So it is not 100 pages every second day. It is just an alarm of that what is really new coming up. That is a small collection what we are doing, what is behind in the background. I think with respect to the time that we have, I will just go through and give a short idea that we do a lot of filtering, a lot of big data mining. We do also, especially on in the analytics on the timeline, we work with machine learning, AI strategies. The local soiling model for every unit is a multidimensional model with a lot of different input factors, not only parameter values and production. There's also the timeline, the model temperature, wind situation as an input parameter. The next thing is then data mining, going back in the other way around, isolating the soiling amount for every tiny unit. So normally it is string level, and then make the summary of all this and generate, make an extrapolation, and with cost benefit, then you can also decide is it necessary to clean or not. I want to show you here some results that are typical in the real life. This is a plant, a 50 megawatt plant in India, in a near desert region, not quite that kind of desert that you have seen on Donald's, but pictures. But they had no cleaning of the pyranometer, and as you see here, the months on the baseline. In July, there was monsoon, that is the yearly annual climate. Speciality that the models are really washed, also the pyranometer is really washed. And in December, they had 25% soiling on the pyranometer, and we are happy that they have a nice performance ratio, but it was just a lie because the model were not clean and the pyranometer was not clean. So enhancement potential at this time more than 20% of the plant. Another example is it's a 250 megawatt asset that where we work as owner representative advisor. We could find out that rain with more than 1 liter per square meter or half a liter for 15 minutes have the same effect as cleaning. So we could here in this case reduce the the cleaning because the local weather situation, and you see here in the lower picture the rain impact, and as soon as this rain impact reaches approximately half of the distance from the baseline to this yellow title, the models are more or less clean. You see that here over the summer season there is a nice cleaning in every plant at least every 3 weeks, so forget the cleaning. How much is the impact over the time? This is my last slide from technical point of view. Here you see a situation on a 15 megawatt plant that is also an example of India, where the soiling situation is quite more impressive than in Europe. Expect Spain and Sicily, but here you see they skipped the cleaning because they need the guys in the parks for some replacement work. And the astonishing thing is the losses grew up to 15% within 4 weeks. Was in some regions of the park, and considering that the cleaning personnel in India is really cheap, they will never do this again. So it grew up to 2,000 euro loss per day on a bad feed-in tariff that they have compared to some European ones. So that has been some kind of overview on how to taking care about the soiling and what is the impact. And I want to thank you for your listening the last 20 minutes, and we'll give back to Eelco.
Thank you, Gerhard. Great work. Very interesting insights. Let me just bring up my own slides again, and then we can get ready for the Q&A. Hold on. So yeah, I'm gonna unmute both of you, Donald and Gerhard.
Back again.
Donald. Donald, can you hear me again?
Yes, I can hear you. I'm loud and clear.
Great. So first question, Donald, impact of soiling changes during the day due to the angle of solar radiation. I think this is actually already answered in the graph you showed. Is that correct?
Yeah.
So is this taken into account?
Yes, it is taken into account by the post-processing of the values measured by the Dust IQ.
Okay, so that's a software thing, right?
Yeah, correct.
Okay. The world map of soiling or of dust that you have shown us, is that, yeah, where did you get it from? What is the source of that data?
Okay, well, I don't know by heart, but I can share that with you later. It's our research and science team that found it. Okay,
perfect. Yeah, for everybody, if you have specific questions that you would like to address after the webinar, if you can find Donald or Gerhard's contact information you can find it either in the recordings that will be available in the coming days, or you can just send me an email, ilko@solarplaza.com, and I will forward it to the relevant person. So let me see what else. Yeah, Gerhard, you already addressed the question on thin film. So the soiling itself seems to be a bit less, but is it correct that there's no that the impact is less because there's no hotspots, etc.
No,
derived from it?
That's not perfect. The hotspots are not that easy. Then on thin film, you have on crystalline, you have still hotspots, especially if the model is not perfect like it is originally from manufacturer. So there are hotspot situations on thin films, but not so critical as on crystalline ones. And you can see it quite near if you take just infrared picture. You will see it.
Interesting. So actually, I think this is if you would like to learn much more in detail about these kind of mechanisms and yeah, very much more on a scientific level, more in depth. I think it would be very good to sign up for the webinars that Greg is organizing with NREL, and we will actually announce these webinars soon in our upcoming newsletters. I've attended quite a few of them, and I'm extremely impressed with the level of in-depth knowledge these guys have. Mainly academic, but it can be still yeah, very interesting and relevant for most of you that operate PV plants in the field. Yeah, I wish I had a slide prepared on that with the link. Sorry about that, but I will make sure it will be announced in our upcoming newsletter. So let me address another question. Donald, with the Dust IQ algorithm, how does it work? Is it instantaneous soiling rate, or is it a daily soiling rate? How do you calculate it?
Okay, the Dust IQ will measure the reflection coming back from the dust on top of the PV panel. You know, it measures from below, and it takes a measurement every minute, just to be in line with the IEC recommendations, which are for 2-panel systems. But you know, we didn't want to be the odd one out, so it measures every minute, and you get a valid measurement every minute, which is the perpendicular one. And that's also why over the day, if you want to have the soiling ratio valid for, let's say, 4 in the afternoon, you would do a little bit of post-processing and in fact get a slightly lower soiling ratio, so more loss due to the soiling. Then again, the IEC recommendation is also for parties to make a weighted daily average, so then they get an average over the whole day, which takes into account the amount of energy produced. So even though the soiling ratio is lower later in the afternoon, the real effect on the weighted daily average is smaller because you're making much less energy. Does it answer the question, Eelco?
For me, it does. Thank you. Just waving some colleagues goodbye here in the office that are about to leave to Chile. Sorry for the distraction. So another question, I think it's to you, Gerhard. Actually today I spoke to Hugo Schoot from DSM, and they actually have some exciting news to share in the coming period of time on nano coatings. So that's very interesting, but do you already have experience with that, Gerhard, with anti-soiling nano coatings, either from the factory or maybe even as part of a repowering process of a plant?
Yeah, we have checked on some of the larger plants from 2010, 2011, where this nano coating was not part of the module manufacturer, and the astonishing effect was that this nano coating is delivering nice results the first few days, but the nano coating is, if you apply it direct on the field, is washed away within the first 2 or 3 heavy rains. So that's the problem that we had with this nano coating. We did measurements on 5 locations on 5 or 6 strings and did compare measuring, and also Donald said the measurement that we're taking are also every minute, and based on the result of every minute, we consider all these daily profiles of the various effects there. And the effect of nano coating was quite nice the first 3 weeks, and it was gone on another example within 1 day after a heavy rain. So 2 or 3 heavy rain and the nano coating is washed away. It lasts much longer and has better effects if you have modules where the coating is done under let's say industrial circumstances or industrial conditions in a manufacturing line. Then the coating looks like it is better on the surface, and these modules stay longer in a better shape regarding coating rate. What is working quite nice is our modules with plastic surfaces, for example, of Das Energy. There are these are and have on the top surface to cover the cells. They have a plastic, and these plastics stay longer on this recoating factor. So these are the solutions. Either you have it coated in the manufacturer, or you don't have glass.
Interesting. I'm pretty sure that DSM is currently in the piloting process. Yeah, hopefully we can they can share some results on this as well in the Milano conference. I'm very much looking forward to it. I know there's a lot of people working very hard on it at DSM. So let's see if they can come up with a coating that is a bit more sustainable and durable than what you have seen. So let's go to the next question. Let me see. So Donald, are the algorithms, or no, actually it's a question to Gerhard. Are the algorithms that you make, that you have made on soiling, is that based on experimental data from the lab or on actual field data?
We have the experience that taking the values from the field is much more successful than taking it from the laboratory, because in laboratory conditions you have most of the time forgotten one of the impact that you have not considered before, especially tiny wind locations, or some local specialities like special growing grasses, or even things like people who threw grass on models. You can handle this much more if you take some kind of this artificial intelligence algorithms on self-learning on the real environment. This is much more precise, but for sure, taking these algorithms, you have to verify it with that was coming from the laboratory. You have to verify it with the background, because the artificial methodologies, if you use them just totally plain without no relation to the reality and no relationship to the scientific world, let's talk so, doesn't work on the other side, because also all these algorithms have also from numerical point of view some pitfalls that you should avoid. And on double checking the results from the field with the expected from the laboratory, or the expected from the laboratory with the results from the field, and on the other hand ensures that this is working on more than one situation. So that's the methodology that we are using normally.
Sounds quite solid to me. Donald, I've seen the Dust IQ, I think it was in Amsterdam a while ago, and there were two sensors in that. Is that to measure soil accumulation on the bottom, or what is the reasoning behind it?
Okay, yeah, a very good question. Indeed, there are two completely independent sensors in there. It will allow a user to have two measurements. If the panel is installed upright, you would have a measurement, lower on the panel and one higher on the panel, and these could be different, depending on the actual soiling on the PV plant. That is one reason. The other reason is that our adagio is one measurement is no measurement, and if you've got two and one is really out of line, much lower, you would already know that you would need to send a technician over there because something might be wrong, or maybe somebody to clean the panel. Especially in more urban areas, or areas where there are, for instance, birds around, people do care much more about indeed bird droppings and then blocking just one of the sensors. And if you have to have two sensors, you could see that and do something about it.
Okay. Well, showing the sponsors of our upcoming conference, you will find the names of Staubli and Syconia. That will actually be on the next webinar, the 24th of October at 3 o'clock, on risk analysis and mitigation with a focus on connectors and inverters. We will announce that in the upcoming newsletters as well. Maybe one final question to Gerhard. It's a classical question, I would say. What is the best product to clean soiling? Just any kind of water, some additive. Does it vary among markets and locations, water quality, etc.?
Cleaning is always a very local topic. You can, as you have seen, one example I've presented, cleaning was just nothing to discuss about after we got this measurement that the rain is cleaning in this local situation. Cleaning is also what you are allowed to do. For example, we have and I'm going here back to India, some locations where it is not allowed to use more water because they have not so much water. So you have to clean dry, and you will have no discussions. We have also situation that normal dust and normal, so the annual soiling you can clean with any cleaning equipment that is on the market, and it's just philosophical the difference that you get between. But as soon as you have some oily components in the dirt in near industrial zones, or the example I told you from the airport, then you have to clean with wash additives. Other way, the permanent soiling will not be washed away from the models. And there are also gluey things, like if you are near a rice field or if you are between a field that is blooming very much, then you have gluing additives in the soil, and then you have to add something. Which methodology? There are dry cleaning robots that deliver really nice results, and most of the time you take water and wash it away.
Okay. Thank you very much, both. I have still 2 announcements to make. So here are our upcoming events. Of course, in Chile, soiling is a big issue, as I said. If you're based in LATAM, please head to the website samlatam.com. Yeah, see who's there. I think we have a very, my colleague Marcel and Hugo did a great job on making it a very mixed and very interesting and relevant crowd on solar asset management in Santiago. So if you're based in LATAM or you have a business in LATAM and you can still make it, work in your calendar, at least visit the website and yeah, check the program. Then there will be a big conference in Abidjan on the 25th, 26th of October, Unlocking Solar Capital Africa, a bit more the development side, of course. Exciting place, nice weather, I assume. So yeah, please look at the website and see what the program is like and who's attending. It looks like it's going to be a successful event again, just like previous, just like last year in Africa. And of course, there's the major solar asset management conference in Europe, 5th edition. So as I said, we will still organize a webinar before that, the 24th of October. The recordings of this one will be available, and I will try to give the microphone to Greg Smeestad. If I pronounce your last name right, I always have a difficult time with that. Greg, are you with us?
You did. Yes. Can you hear me?
I can, very well,
good,
thank
good.
you.
It's
great to have you here, Greg.
Yes, thank you. It's a good Norwegian name from north of Oslo. So we have a PVQAT, that's the Quality Assurance Team, a Technical Group 12 webinar on Tuesday, October the 17th, as Ilko said. That's at 8 a.m. Denver time, Mountain Time, 7 a.m. For us here in California, where I am. If you'd like more on that, you can email me. That's inquiries@solideas.com, or I can rattle off the email address, or Ilko can send it in a subsequent email to you.
That's also correct.
Yes, that's also a go-to webinar. It's this wonderful platform that Solarplaza uses as well. So mark that on your calendar, October the 17th at 8 a.m. Denver time. That's next Tuesday. on. The topic will be soiling measurement stations, and our speakers will be Campbell Scientific and also Tonometrics.
Great. Yeah, like I said, it's always very interesting to attend these webinars. I enjoy them very much. And yeah, sorry about not having the slide prepared on this, Greg. I promise that I will do a better job in the future on announcing the exciting and very interesting content you guys are working on. So thanks for that announcement, Greg. And yes, thank you everybody for attending. Thank you speakers, thank you sponsors, and we are very much looking forward to meet all of you in our upcoming conferences, as you can see here. There is actually a discount code available for the conference in Milan. So let me put that up to finish the webinar. So the first 10 people that register will get a 10% discount by using this code. Well, looking forward to see you in Milan, and for now, have a great evening.
Yeah, thank you, Ilko, and thanks everybody, and thanks Gerhard for your good presentation.
Thank you, Donald. Thank you, Ilko, and thanks to the audience, the last 57 that are still online.
All right. Thanks, guys. Speak to you soon.